Loop is a very important structure in programming. Loop allows you to do repeated tasks. So if you want to do repeated tasks like want to count 1, 2, 3, 4, so on, it helps you to do that count very easily. If you have to repeat code or do certain things again and again and again, loop actually will help you do that. So suppose you want to print welcome to Java multiple times, and how would you solve that problem? So if you want to do something like this, one way of doing it is copying that string 100 times. Copying the statement 100 times will is a slow way of doing it. Plus if this becomes 1 million, then how are you going to do it? It just takes you forever to do it. You will be doing it for years to come. That said, there is an easy way of doing it. You can use something called a while loop and have a count which basically starts from 0, increments a count. So this statement actually is same as count is equal to count plus 1. So what it does is it starts with 0, then it comes in here, it first checks if it is less than 100. Yes, it is. Then it adds 1 to it, so it says 0 plus 1, that becomes 1 now. Goes back, check if it's less than 100, then adds 1 more, then it becomes 2, then adds, so keeps on going till it reaches 99. So 99, so it starts from 0, goes up to 99. At 99, it prints this statement. So you'll have the 99 time. Then it says count is equal to count plus 1. Count becomes 100. 100 is less than 100? No. So this part returns false at 100, and then this comes out of the loop essentially. That's why you see 100 welcome to Java printed on the screen, and then it comes out of the loop. So while is one way of doing loops. So what we are going to do is we're going to learn a few things. We're going to learn while, we're going to learn do while, for, and a few other things as we go along. Break and continue, two important statements. So how does it go? So you have a while loop which has a condition that if satisfied, it'll keep on going. If not satisfied, it'll come out. So if it's true, then it does this part of the code, keeps on doing that part of the code, keeps on checking. If checking is false, at one point this condition becomes false, it exits the loop and comes out. So if you look here, count is 0. If count is less than 100, then true, then it'll keep on printing. As soon as count becomes equal to 100, it'll say false, and it'll just come out here. Similarly, you see, initialize the count to 0, count is less than 2, so, and count plus plus, so it initializes count, then count is less than 2 because count is equal to 0 to start with, and then it prints this guy, and then next step it becomes count, it prints this guy, the next step it becomes count plus 1. Now count is equal to 1, 1 is still less than 2, then 1 is less than 2, then it prints this one again, and then it increments this to 2, so it prints it again, then it increments to 2. As soon as it increments to 2, 2 is not less than 2, it is equal to 2, and it at that point this part is false as it says here, and it comes out, basically it comes out to this part and it exits the loop. That's it. Okay, so you have a program that prompts the user to enter for questions for 2 single digits using a loop. Can you rewrite the program? So let's see, we can do this too. Guessing game, it's part of the video as one of the assignments. Okay, so another important thing to actually check is we do not use floating point numbers because count is always integer. If you use floating point numbers, there could be numbers between, if say 0 to 1, there could be 0 0.1, 0 0.2, 0 0.3, and so on. Many numbers between 0 and 1 if you use a floating point number. If you use an integer, then there are 2 numbers only, 0 and 1. So if you want to increment 1, 2, 3, 4, integer is best case because there is no guarantee in floating point that the number is going to be 0, 1 or anything, That's why it's good to use integer versus floating point for counters. That's it. Now there is something called a do while loop. So do while does this part of the code while this condition is true. So it says it executes the statement body, then checks if this part is true. If it is true, then goes back and does that statement again. Then checks again if that part is true, then goes back and does the statement again until this part is false. Once it's false, it just exits the statement, so it'll come out. Similarly, there is something called a for loop. So for has a starting point, has a condition that checks for the ending point, and condition that increments. So three things though. So it starts at 0, goes up to 100 till I is less than 100, and increments by 1. And it'll print this. So initial action, the initial number, loop condition, and the action at each iteration. Okay, so how it works is it checks basically if it is meeting the condition. If yes, then it does this part of the code, which is in the brackets, basically this part of the code. And then if the action is false, then it exits and this thing. Similarly, if I is equal to 0 here, and if I is less than 100, it keeps on doing welcome to Java and increments the counter, goes up. If I is still less than 100, it'll do welcome to Java again. Keep on going till I is equal to 100. As I is equal to 100, it'll be false and it'll come out. So now let's try tracing it. So you see you declare I here, and I is declared first step. Then we execute. Now I is equal to 0, starts with I equal to 0. Then I is less than true since I is equal to 0. Then we say, oh, then it prints this statement. Then this increments, so this is the same as I is equal to I plus 1. Then we have I less than 2 is still true. Till the time this remains true, this loop will continue. Now it will print the welcome to Java again. Then I increments again by 1. Now I is 2. Now this doesn't remain true anymore. So this is false, it doesn't remain true. And then it exits the loop. So how does the loop work? So loop has start, end, and increment. So it can start at, you can also start at I equal to 5. You can say I less than 10. And then you can say I plus plus. And you can also say int I equal to 5. So in this case, it starts from 5, 6, 7, 8, 9. This is what it actually outputs. So this starting point, it could also go I minus minus, then it can, and then I greater than 0. So you can do I equal to 5, I greater than 0, I minus minus. So it starts with 5, minus minus 4, 3, 2, 1, and then 0 is not greater than 0. This is false and it just comes out. Two examples. So initial action for loop can be list 0 or more comma separated expressions. So you can have more though. You can have ij 0, I plus j less than 10, I plus j plus plus. So what it does is it will increment I after one loop and j after one loop. So I is equal to I plus 1 and then j is equal to j plus 1. This is how this works out. And then it checks for both I and j less than 10. So that's one way of doing it. Also, you can also do something like this, which is rare, but this will output, this is output the I value. Similarly, it's generally equivalent to this for loop is generally the same as while loop. So given a for loop, it's good to know what a while loop does. So given a for, writing a while is good practice. So logic error. So there is a possibility that you may put a semicolon at the end of it. That's an issue. At that point, this gets executed and the control doesn't go into this bracket. So this code will never get executed if you put a semicolon here. This is a problem. Now similarly, following loop is also wrong. So if you put a semicolon at the end of while, it will not go into this part of the code. So it'll keep it out. So this is a logic error, essentially. So what logic error is? And similarly, if you do something and put a while after that, this seems to be okay. But not this, because this means that this is finished and it will not execute this. Similarly, you have while here, and then you can do while, which is the same as this thing, loop condition, and then you can actually, this loop condition and this loop condition is the same. Similarly, you can do something like this, where your initial action, your condition, and the iteration value, which is the same as while, and changing the iteration value here, the action for each iteration value. Recommendation. You'll need, so in general for a loop, it will be if the number of repetitions is known. For example, when you need 100 times, while loop may be used if the number of repetitions are not known. Keep in mind, if the number of repetitions are known, you actually use a for loop. If the number of repetitions are known, if known, you use for. If not known, then you use while. So do while can be used if the body has to be tested before the checking continuation condition. Then you use a do while. But this is the general this thing for for and while loop. Nested loops. So nested loops is a loop in a loop. So if you have a for loop and you have another for loop, basically, so I is equal to 0, I less than 10, I plus plus, and then you say for j equal to 0, j less than 10, j plus plus. That is basically a nested loop. So a loop is running and there's another loop in running. So what does that mean is that this loop is going to go on 100 times. So the first loop is going to go, that will execute 10 of these. Then the next increment, so I is equal to 0, and then j is equal to 0 to j is equal to 10, and then I is equal to 1, then you'll have 10 of those, so j is equal to 10 again, and then I equal to 2, and so on. So this is how a nested loop actually works. So numeric errors, floating point inevitable. So how to minimize numeric errors. So for example, sum of a series that ends with 0 add with, so finding the greatest common divisor, predicting future tuition, and then tuition is this thing. Okay, converting hexadecimals to decimals, and Monte Carlo simulation we can talk about, and break and continue. So these are two important things to actually talk about. One is break and one is continue. Break exits the loop, and break will exit the loop, and continue will increment the counter. So if you look at it, break will exit, and it'll so while less than, so if you say break, essentially the numbers add up to be 7. Break will exit this loop and come out and print these guys. So this will get printed after break. So break is used to exit any loop. That means this piece of code in between these brackets will stop executing, and it will come out and do the next thing under the loop. Continue will move on essentially, and it'll go back and start this loop again. So that will be continue essentially, and it'll keep on going essentially. So if number is equal to this thing, so it'll go back, and then it'll keep on doing the loop, like it'll just as an increment actually happened. You can make a guessing game. Palindrome is essentially the So first and the last are same, second and second last are same, third and third last are same, fourth and fourth last are same, fifth and fifth last are same, and so on. You know, that's how a palindrome actually works. Prime numbers, and that's about it.